Dad Automation, your automation partner.
Have you ever wondered how a proximity sensor detects objects without touching them? In this video, I will show you what's inside an industrial proximity sensor and how it really works step by step. Proximity sensors are mainly divided into two types. Inductive sensors detect only metal objects using an electromagnetic field. Capacitive sensors can detect both metal and non-metal materials like plastic, liquid, and wood. A capacitive proximity sensor works by creating an electric field in front of the sensor. When an object enters this field, it changes the capacitance between the sensor and the target. This change is detected by the internal circuit, and the sensor switches its output. An inductive proximity sensor is used to detect metal objects without contact. It works by generating an electromagnetic field from a coil inside the sensor. When a metal object comes close, it disturbs this field, and the sensor switches its output. The sensor is used for liquid level detection. The sensor can detect the presence of liquid through a plastic or glass container without direct contact. This is very useful in tanks, bottles, and chemical containers. The second image also shows liquid level monitoring in an industrial setup. When the liquid reaches a certain level, the sensor changes its output signal. This can be connected to a PLC or control system to start or stop pumps and generate alarms. The third example shows non-metal detection on a conveyor or guide rail system. Capacitive sensors can detect materials such as plastic, paper, wood, glass, or rubber because these materials affect the electric field around the sensor. In the final example, the sensor is used to detect wooden pallets on a conveyor system. Since wood is a non-metal material, an inductive sensor cannot detect it, but a capacitive sensor can easily identify its presence. This diagram shows the internal working principle of an inductive proximity sensor. An inductive proximity sensor is mainly used to detect metallic objects without physical contact. At the top of the sensor, there is an active surface. Behind this surface is an inductive coil connected to an oscillator circuit. The oscillator generates a high-frequency electromagnetic field in front of the sensor. Under normal conditions, this electromagnetic field remains stable. When a metal object enters the detection area, eddy currents are induced in the metal surface. These eddy currents absorb energy from the electromagnetic field and reduce the oscillation amplitude. The oscillator electronics continuously monitor this change in oscillation. When the change reaches a specific level, the signal is sent to a Schmitt trigger circuit. The Schmitt trigger acts like a decision-making stage. It converts the changing analog signal into a clean digital on or OFF signal. Finally, the output switching circuit activates the sensor output. This output can then be connected to a PLC, relay, or industrial controller for machine automation. So, in summary, the inductive proximity sensor works by generating an electromagnetic field and detecting changes caused by nearby metal objects. This allows reliable and contactless metal detection in industrial automation systems. This diagram explains the working principle of a capacitive liquid level sensor. In the center, we have the sensing electrode called the liquid sensor, and on both sides there are ground electrodes mounted on the PCB. When no liquid is present, the capacitance between the sensor and ground remains low. But as liquid approaches the container wall, the electric field lines extend outward and interact with the liquid. Because liquids usually have a higher dielectric constant than air, the capacitance value increases. The sensor electronics detect this change in capacitance and determine that liquid is present behind the container wall. One important advantage of capacitive sensors is that they can detect liquids without direct contact. This means the sensor can work through plastic, glass, or other non-metallic container walls. That is why capacitive sensors are widely used for liquid level detection in industrial automation, food processing, chemical plants, and water systems. Now let's understand one of the most important topics in industrial automation, PNP and NPN sensor outputs, and how they connect to a PLC. At the top left side of the image, we can see a PNP output sensor, also called a sourcing sensor. This sensor has 3 wires. Brown wire is connected to positive 24 volts DC. Blue wire is connected to 0 volts or ground. Black wire is the output signal wire. In a PNP sensor, when the sensor detects an object, it sends positive voltage to the load or PLC input. That means the sensor is supplying current to the output. This is why it is called sourcing output. In simple words, when detection happens, the black wire becomes plus 24 volts. Now let's move to the right side of the image. This is an NPN output sensor, also called a syncing sensor. Again, we have three wires. Brown wire connected to positive 24 volts. Blue wire connected to 0 volts. Black wire is the output signal. But here the operation is different. When the sensor detects an object, the output switches to 0 volts or ground. Instead of supplying positive voltage, the sensor provides a path to ground. That is why it is called syncing output. So in simple terms, PNP gives positive voltage to the PLC input. NPN pulls the PLC input down to ground. Now let's look at the middle section called connection to PLC. First, we have the proximity sensor. The sensor detects a metal or non-metal object depending on the sensor type. Next, the signal goes to the PLC input module. The input module reads the ON or OFF signal coming from the sensor. Then the PLC controller processes the logic according to the program written inside the PLC. Finally, the PLC activates output devices such as warning lamps, relays, contactors, or motors. So the complete signal flow is: sensor detects object. PLC receives the signal. PLC processes the logic. And output devices perform the required action. Now let's look at the bottom left section called Other Output Options. Some industrial sensors provide analog outputs instead of digital outputs. For example, 0 to 10 volts or 4 to 20 milliamp signals. These analog signals are used for measuring continuously changing values such as level, pressure, temperature, or distance. But for simple on and off object detection, digital PNP and NPN outputs are the most commonly used types. Finally, let's summarize the key points. PNP sensors source positive voltage to the load. NPN sensors sync current to ground. Both sensor types are widely used in industrial automation. And PLC systems read these signals to control machines and industrial processes. Understanding the difference between PNP and NPN is very important when wiring sensors to PLCs, because incorrect wiring can prevent the system from working properly. And that's the basic working principle of PNP and NPN proximity sensor outputs and their connection to a PLC. Industrial proximity sensors must be installed carefully to achieve reliable and accurate performance. This guide highlights the most important practices for proper sensor installation in industrial environments. The first step is maintaining the correct sensing distance. Sensors should always be positioned within their recommended operating range so they can detect objects consistently without false signals or missed detection. Proper mounting is also important. Depending on the application, sensors may be installed using flush or non-flush mounting methods. Flush mounting allows the sensor to sit level with a metal surface, while non-flush mounting provides a larger sensing field for general applications. Electrical interference can affect sensor performance. Sensor cables should be routed away from motors, high-voltage power lines, inverters, and welding equipment. In noisy environments, shielded cables may be required to maintain stable operation. The sensor must also be mounted securely. Loose installation can cause vibration, movement, or misalignment, leading to inaccurate sensing and equipment problems. Keeping the sensing face clean is essential for long-term reliability. Dust, oil, dirt, and material buildup can reduce sensing distance and create false triggering. Regular inspection and cleaning help maintain proper operation. Environmental protection is another key factor. Sensors used in harsh industrial conditions should have suitable protection ratings, such as IP67, to resist water, dust, and contaminants. Choosing the correct mounting type depends on the application. Non-flush sensors are commonly used for longer sensing distances, while flush sensors are preferred when installation space is limited or when the sensor must be mounted inside metal structures. Following the manufacturer's installation guidelines ensures better performance, longer service life, and reduced maintenance problems.